Hello, welcome at Tech Talk episode 5. As you might know by now, here I will answer as many questions as possible on our products and also on system related questions. If you have any questions left after watching this clip, you can leave them below in the comments bar and I will try to answer them next time. In this episode I also have some exciting news besides answering the questions, so stay tuned after the questions. The first question that I got is from RMA, and RMA is asking what is the advantage or disadvantage of using a VE Direct communication or a VE CAN communication between an MPPT and a servo. Well, RMA, the difference is actually that a VE Direct port is a serial port, so that's a more cost-effective port. That means that if you have multiple units, you also have to do multiple wiring. And on a CAN communication, you can daisy chain the units with each other. DVCC works on both protocols, so that's not a difference. It's only when you have larger systems, well, then VE CAN is preferred. If you have smaller systems, you can also do with VE Direct. The second question is coming from Ralph. Ralph is asking, I'm getting a new boat with all Victron systems. Lithium batteries, inverter chargers, a servo and controllers, the whole lot. I'm very excited about this, but I'm curious, why do you guys have a BMS outside the battery? Well, Ralph, first of all, congratulations on your new boat. We're happy that you choose Victron, of course. On the battery, we have two options. We have the batteries with an internal BMS, so on a low cell voltage or high cell voltage, they will just disconnect them from the load or from the charge source. And we have also lithium batteries with external BMS. Of course, with an internal BMS, it's easy installing. On an external BMS, you have more options for voltage. You can have 12 volt, 24 volt or 48 volt, because with an internal BMS you cannot serial connect these batteries, because if one battery goes off, the other one cannot switch it on again. So for the smaller systems, most of the time we use drop-in lithium batteries which have an internal BMS. For the more larger systems we use the smart lithium batteries. They have an external BMS, so you can choose for yourself how big your system should be and also how your charge current and discharge current should be handled. The third question is coming from Tiny Solar, and Tiny Solar is asking, hello Johannes, I wonder if you could explain the connections to ground in a mobile application. I'm thinking the battery negative are connected to the chassis on one side of the shunt, and the other side of the shunt is a negative as far as a 12 volt system. Well, it's actually like this. You have the negative side, and the negative side is what the battery is concerned. So for the battery point of view, the shunt comes in the negative of the battery. Besides that, you have also the ground, which is the safety ground. So your the load side of the battery and also the minus of your AC system is connected to the chassis. That means that for safety potential, that part is used. So the shunt is coming between the minus and the chassis, and the neutral of the inverter is coming also through the PE connection, or your ground relay connected to the chassis as well. So your 8-volt relays breakers will be tripped by that. The fourth question is coming from Santiago, and he is asking, how does a Cyrix battery combiner actually works? Can I charge from the alternator two different sizes and types of batteries? It disconnects the alternator where the battery is full, right? Well, yes, a Cyrix is actually a relay with a smart algorithm in it. So it detects if the battery is being charged from either side, so from the starter battery where the alternator is connected, or from your house charger on your house bank. And it can work bidirectional, so it can also charge the other way around. The Cyrix is smart, so it knows if there is a charger being switched off, so it knows when the voltage is going down on a slow pace when to open, but also can detect if there is a high load, just as a boat thruster. And if there is a high load, then the voltage will drop very fast, and then the Cyrix will keep on closed because it wants to use as much energy as possible. So it detects when a charger is being switched on or off, and it can also detect if a load is being switched on and off. If you want to charge different sizes batteries, that's not a problem because it's all about voltage. So you can have different sizes, a small starter battery and a large household battery, and the Cyrix will still be able to do that. If the balance is really off, so you have a very small starter battery and a very small alternator and a used house bank, it could be that in the beginning of engaging the Cyrix will switch off a few times because the voltage is not rising fast enough, but in the end that will be okay. Different chemistries is a different story because the charge voltage you apply to one battery is also the charge voltage you will be applying to the other battery. That means you have to have a lead acid battery on one side and a lead acid battery on the other side. If you have different chemistries, like a lead acid battery starter battery and a lithium household battery, then you need also a specific model of Cyrix, and that's called the LE model. So it depends a little bit on which battery types you have, which Cyrix to use. But it is possible that you can use that on multiple sizes of battery bank and also different chemistries. The fifth question is coming from Seam, and Seam is asking, why does a MultiPlus, let's say a 3 kilowatt, need a 5 kilowatt to charge the batteries? How can I use a smaller generator? Well, the point is, Seam, that a MultiPlus is taking power from the generator to charge the battery. So in order to have the maximum power for a charger, it also needs enough AC power coming in. If your generator is not big enough, the voltage will drop, and then of course the multi will reject the AC power from the generator. So then you have two options. You can reduce the charge current so that the energy is less coming from the generator, but you can also limit the AC input limit. The AC input limit reduces the charge automatically because it expects the generator to be smaller. What you should do when you have a generator connected to the multi is at least switch off the UPS mode. The UPS mode is sort of a check on the sine wave, and as you know, a generator doesn't have a perfect sine wave. So if you switch off the UPS mode, then also the multi will allow the generator to be not as perfect sine wave wise as the grid connection would be. So the UPS should be switched off, and then the AC limit should be, well, somewhere around 80% of what a generator nominal can do. This was the last question of this episode. If you have questions and you want me to answer them, please leave them at the comment bar, and I will be happy to answer them next time on the next episode. And we have some new product as well. And one of the first products I would mention is the Lynx Smart BMS. As you know, we have a variety of BMSs, but for the larger system we were still lacking one, and that's the Lynx Smart BMS. It's a BMS which has an integrated contactor, so you will cut off the batteries if something goes wrong with your system. So if you have a low voltage on the cell or a high voltage on your cell, the system itself will shut itself down. Here on the schematic you can see that also the Lynx Smart is interacting perfectly with the Lynx distributor. It's even so nicely integrated that you can read out through the Lynx Smart BMS what the status of your fuses are. So it interconnects with the Lynx distributor, and then the whole overview of your DC system will be visible on the VRM side. Of course, the Lynx Smart BMS has a Bluetooth connection, so you can set it up quite easily. It has a 500 amp contactor, and it will also work with pre-alarm. So before switching off at an alarm status, you can also enable an alarm for a buzzer or an LED to warn you that something is about to happen. Speaking of BMSs, as you know, the BMS needs to interact in the system, because sometimes you have to cut off your charge sources, and sometimes you have to stop your inverter or other DC loads. Well, you could do that with a relay, but the negative side of using a relay is that the idle power is quite high. That means it will drain your battery over time. So better is to use something like a Battery Protect. Well, the Battery Protect has a very low idle consumption, so it's able to switch off DC loads or other things very effectively. But of course, when you have a Battery Protect, a lot of times the current which you switch is quite low. So if you want to control, let's say, an external charge controller for your alternator, the current that you switch is actually, well, 1, 2, 3 amps, something in that range. So for that we have now the Solid Switch 104. The Solid Switch 104 actually works the same as a Battery Protect, but is a much smaller device. The Solid Switch can be used up to 70 volts. So it uses a small signal from the BMS, and it allows you to switch a current up to 4 amps in your system. The last exciting news that I have, you can already see it here on the table, is the new MultiPlus 2 50 amps. And 50 amps in this case stands for split phase. That means this unit can be hooked up on a split phase network, and it allows you to forward the full split phase to your system. That means if you're hooked up to the shore or your landline, you have 240 and 120 volt in your system, and when you're in inverter mode, the unit will switch itself over to 2 times and 120 volt. That means in inverter mode you can feed your whole AC distribution with 120 volts, and you're in pass-through, you have 120 volt and 240 volt. This unit is now available in 12 volt, so it's ready to order, and late this year, perhaps Q1 next year, also a 24 volt model will be available. So this was all for now. Thank you for watching, and I hope we'll see you in another episode. Bye!